Good morning. Today we are going to talk about exponential functions and logarithmic functions. Now, just like I said a couple of times when in the last couple of lessons, I like to think about logarithms as in terms of exponents. I do the same thing every time that I think about graphing an exponential function. So we're gonna start by looking at an exponential function. Now, what I should have said before, if you want to pause the video, I left graph paper for you all. You know how I like to hot dog fold and hamburger fold. I would strongly suggest you take your graph paper and you do a hot dog fold and a hamburger fold so that you have 4 sections. I'm going to write in the top section, graph on the bottom, write in the top section, graph in the bottom. So we are going to graph an exponential function of y equals 2 to the x. Y equals 2 to the x. We've been talking about exponential functions over and over for the last week we talked about exponential functions. This is our zombie relationship that we're multiplying by 2, multiplying by 2, multiplying by 2. So I'm going to plug in some values here. If I am at x and y, let's go with the easiest, 0, 1, 2, and 3. If I plug in 0, 1, 2, and 3, 2 to the 0 is going to give me 1. Exponent rule. Anything to the 0 power is 1. If I plug in 2 to the first, that gives me 2. If I plug in 2 squared, that's going to give me 4. And if I plug in 2 to the third, it's not 6, it's 8. So these are some coordinates for my exponential. My y-intercept is at 0, 1, and then I'm going to have 1, 2, 2, 1, 2, 3, 4, and 3, 5, 6, 7, 8. So as you can see, we have that exploding exponential function. We're going up to the right. And then I can plug in, I don't have to be in just quadrant 1. What happens if I plug in a -1 and a -2? 2 to the -1, if you remember my loves, negative exponents move us from the numerator to the denominator, so that becomes 1/2. So at -1, I'm going to be at 1/2. And if I have 2 to the -2, still following our exponent rule, we go 1 over 2 squared, and then that gives us 1 over 4. So that's 1/4. We are going to get lower and lower and lower and lower, closer, 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 closer to our asymptote. We love that word. Our asymptote is going to be here at y equals 0. It's a horizontal line, and so we have an asymptote at y equals 0. For those of you who love domain and range, if we were talking about domain and range, this, I don't have any place, if I should do it the other way. I'm going to, as I go to the right, my function is going to keep going and going and going. As I go to the left, my function is going to keep going and going and going. So that should be an indicator that my domain is all real numbers. Is all, well, come on, Miss Baker. We'll just do A-R-N, all real numbers. Or if you like negative infinity to positive infinity, I'm good with that. But my range is what part of the y-axis are we using? So if we go and get this highlighter, I'm not going past 0. I have no points down here past 0. All of my points are up here. So I'm never going to have a negative y value. So that means my range is going to be y has to be greater than 0. I can't even be equal to 0 Because if I cut it in half and half and half and half and half again, I'm never, ever going to be all the way down to 0. So if you wanted to write that in interval notation, I start at 0 with a parentheses, not a bracket, and I go to positive infinity. This is my range. Ooh, that didn't work. This is my range. What part of the y-axis am I using? And my domain is what part of the x-axis. Now, I know that some of us are still stuck on the fact that math was created to make you miserable, but it's not. Math is created so that we can predict the future. And all of the different functions that we have are ways that we predict the future. Logarithmic functions are just another function that has it's been found over and over and over, and so we created a way to represent a logarithmic function. A logarithmic function, and we'll make them in purple because purple's the best color. Logarithmic functions, ooh, that's highlighter. I don't think I want that. They are going to be the inverses of exponential functions. If we have a logarithmic function, logarithmic, that's hard to spell. I'm just going to call it from logs right now. Function. If we have y equals log base 2 of x, and we want to figure out what that's going to look like, hold on just one second. I have my table for my function of y equals 2 to the x. The logarithmic function is just going to be the inverse of that. So where I have 0, 1, my logarithmic function is going to be 1, 0. I have 1, 2, I'm doing my inverse, 2, 1. 2, 4 is going to be 4, 2. 3, 8 is going to be 8, 3. Even the 1/2 comma negative 1 and 1/4 comma negative 2, those are all going to be points on my logarithmic function. I cannot do it any other way. If I have to do it by hand, this is the only way that I take whatever my base is, I find the exponential function, and then I start flipping things around. That's just how my brain works. So if I want to graph this 1, 0, instead of having a y-intercept, this is going to be on our x-axis. It's our x-intercept. 2, 1, 1, 2, 3, 4, 2, and 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. If you go over a half, we're down to negative 1. If you go over a fourth, we're down to negative 2. So this, if you think about it, should be a reflection over the line. I hope somebody's saying y equals x in there. Are you saying y equals x? Remember, if you, we're getting closer and closer and closer and closer. Instead of having an asymptote at y equals 0, my asymptote is going to be at x equals 0. They are the inverse of each other. Any place where there is a y, we're going to flip it with an x. We also can talk about our domain and range. Here, my domain was all real numbers. So now my range is going to be all real numbers. All real numbers, negative infinity to positive infinity. We also, because look, we're going anywhere. We can go, we're going up, 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 down, 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 down. There's no place that we have a stop in our range. However, we aren't going past 0 on the x-axis. 2 and 3 are completely empty. That's because if you think about flipping this, my range was y had to be greater than 0, so now my domain is x has to be greater than 0. And you can still use that same intervaltation of 0 to infinity. It's just the way my brain works. Every time I think of logarithmic functions, I have to do it in terms of exponential. I've got 5 minutes, so I'm going to try to squeeze one more in. You have a whole sheet of graph paper, You can use the back of the sheet of graph paper right now. If we have y equals, let's just do 3 to the x, which is going to give me an inverse log function of y equals the log base 3 of x. They are inverses, so I'm just going to find my x and my y. 1, 2, 3. I guess I could have started with 0. I'll throw it in there, and let's do -1. So 3 to the first is 3. 9, 27. Obviously, I don't have room for that. Anything to the 0 power is 1. And the -3 to the -1 is just going to become 1/3. So -1, I'm at 1/3. 0, I'm at 1. And 1, I'm at 1, 2, 3. 2, I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9. Exponential. Just like those savings accounts. Just like all of my wonderful students who are going to choose to put money in their retirement account in their 20s because it explodes. You need that time. And then if I wanted to write I better do it. Mr. King will want me to write the domain and range. There's your shout out, Paul. If I do the domain, I still, anywhere on the x-axis, I have points. So this is all real numbers. My range, my y's, have to be greater than 0 because I still have an asymptote at 0, at y equals 0. If I graph my logarithmic function, we are going, oh, I don't know what I'm doing. Sorry. I just need a table. I'm going to flip my x and y's because I'm finding the inverse. 3, 1, 9, 2, 27, 3 obviously isn't going to fit. 1, 0, and 1/3 -1. So 1/3 -1. 1, 0. Can't fit that one. I can fit 1, 2, 3, 1, 4, 5, 6, 7, 8, 9, 2. It is like taking that exponential and just reflecting over that line, y equals x. If I drew it in over here just so you could see, taking that exponential, 1, 2, 3, 1, 4, 5, 6, 7, 8, 9. For my, not up 1, up 2. For my visual people, you should be seeing that this is a reflection about the line y equals x. And I'll even put it in there for you. This line, let's see, 1, 2, 3, 1, 2, 3. There we go. It's reflecting about that line. Both of those points should reflect. All right, you guys have another video that you need, or actually you have one video that you've watched. Here's another video, and you got some practice problems on your shifts of logarithmic functions. They shift just like any other of our parent functions. Hope you have a great day.